Homework 2.1, Basics of Functions, Video 1. Homework due Friday, May 22nd, 2020 at 11:59 p.m. You know, I brought my daughter's Texas State cap because she'll be going there next year. And for some reason I haven't put it on. So here it is. Go Texas State. All right, you may notice that this due date is different than the previous homework's due dates. That's because this homework is the first homework that is on test 2. It and its homework, test 2 and its homework, will all be due at 11:59 p.m. on Friday, May 22nd. Test 1 and all of its homework is due at 11:59 on Saturday, May 16th. So if you're watching this video and you haven't taken test 2 yet, haven't taken test 1 yet, it means one of two things. You're watching this video before test 1 is available, or you're watching it after it was available. Not sure where that sentence was going. But anyway, if you're watching this video and you haven't taken test 1 yet, and it is available, you need to pause, go back and review the previous 4 homework assignments, go in and get that test out of the way, then begin. Now some of you may be working on this before I've made the test available, which is perfectly okay. But keep in mind, that's homework 2.1, Basics of Functions, is the first material on test 2. All right, this first video is kind of a definitions and easy examples video. We're going to define relation, domain, range, and function. And you've probably heard of some, if not all of these words in a math class, but let's just start by defining all of these things. In math, a relation is simply a set of ordered pairs. An ordered pair meaning 2 things paired together where the order matters. So if we said 5 and 3, that's different than 3 and 5. 5 and 3, 3 and 5. Now usually those are pairs of numbers, but there's nothing in the definition that says they have to be. Most of ours will be numbers. Now within a relation, actually before we define these, let's take a look at a couple of relations. In this first example, I have a relation that consists of 4 ordered pairs. 2, 4, 3, 9, negative 2, 4, and negative 3, 9. When a relation is listed as a set of ordered pairs, it's usually included inside of braces, as most sets are. You can also represent a relation with a table. Now notice that I've labeled the columns X and Y, but the names X and Y are actually arbitrary. They can be called anything that I want. Most people know that in an ordered pair, the first coordinate is usually called the X coordinate, and the second one is called the Y coordinate. But again, the names X and Y are fairly arbitrary in applied math classes or classes that apply math, such as physics and engineering. Sometimes different letters are used, such as T and V for time and velocity, or a variety of other letters that could represent some measurable quantities. But generically, the coordinates are known as the X coordinate and the Y coordinate, but even more generically, the first and second coordinates, which brings me to the definition of domain and range. Most people remember from algebra that domain is the X's and range is the Y's. That's not wrong, but to define them independent of X and Y, the domain is the set of first coordinates in a relation, and the range is the set of second coordinates in a relation. In your homework, specifically questions 1 through 4 in homework 2.1, you have some questions that literally ask you what's the domain and range. So why don't we answer that for these before we define what a function is? You're probably hoping that you'll have a lot of questions like this on test 2. You'll have one, but only one. What is the domain of this first relation? Literally asking you, what are the first coordinates in all of the pairs? Answer in the order in which they're written: 2, 3, negative 2, and negative 3. It really doesn't matter what order you write them in, as long as you have them all written. What's the range? Well, the range is the set of second coordinates: 4, 9, well, there's another 4, and there's another 9. So here's a little something you need to know about writing domains and ranges. If you have a repeated value, you only have to write it once. So the first element in the domain is 4, second element in the domain is 9. I've already got 4 and I've already got 9, so that's all that's in this relation's range, 4 and 9. Pretty small range. Let's take a look at the second one. Well, this example is easier to separate the domain and range because they're already separated for you. The elements of the domain are in the column under X. The elements of the range are in the column under Y. But in the homework, when it asks you to list the domain and range, it is not going to let you repeat values. So for the domain, I can't just put 2, 1, 0, 1, 2 because I have some repeated domain values, but I can say 2, 1, 0, and that's all I can say because there are no other different values in this relation's domain than 2, 1, and 0. But the range, there are 5 pairs and all 5 Y values are unique. So this range does contain 5 values, -2, -1, 0, 1, and 2. So sometimes the domain and range is an easy question to answer. Domain is the set of first coordinates in a relation. Range is the set of second coordinates. But there's another definition, and this is the main one in this whole chapter practically. Function. The reason we have to define it last is because its definition uses all 3 of these terms. A function is a relation such that each value in the domain is paired with exactly one value in the range. Let me say that again. Each value in the domain is paired with exactly one value in the range. To be a function, your domain has to satisfy a criteria. The criteria is everything in it has to be paired with exactly one value. So we're going to go to both of these relations and ask, are you a function? And in order to answer it, we have to grill each member of the domain and ask it a question. The question we're going to ask of each element in the domain is, how many range values are you paired with? If the answer is always 1, then you're a function. So let's give it a try. I'll tell you right now, of these 2 relations, one of them is a function and one of them is not. Which one do you think is a function and which one do you think is not? Let's check the first one. Is this first relation a function? So it's a yes or no question. But in order to answer it, we have to grill every value in the domain. We have to ask every domain value, how many range values are you paired with? So let's start with the first value in the domain, the number 2. Excuse me, 2. Yes. How many range values are you paired with? Well, let's find all the pairs with the 2 in front. 1. That's it. This 2 is paired with only one value, that one. So he satisfies the criteria for being a function. This domain value is paired with exactly one range value. And then we do the same thing for all of them. Hey, 3. How many range values are you paired with? I don't know. Let me see how many ordered pairs start with a 3. There's 1, and that's it. So the 3 is okay. The only range value it's paired with is 9, so there's only one value it's paired with. Now let's go to the -2 and ask it the question, how many range values are you paired with? I don't know. Let me find all the ordered pairs that start with -2. This is the only one. -2 is paired with only 4. So -2 is paired with precisely one range value. He's okay. And of course, -3 is okay also. The only ordered pair with -3 is this one, so -3 is only paired with a single range value. Now some of you might be thinking, but wait a minute, 2 and -2 are paired with the same 4. See? You're not wrong, but the definition of a function is a criteria on the domain elements, not the range elements. You only have to ask each domain elements, how many values are you paired with? And if every one of them say 1, then you're a function. Think of it this way. Let's pretend that we have a vending machine that dispenses soft drinks, Cokes if you will. And we have 4 buttons on here. Let's say the first 2 say Coke, and the next 2 say Dr. Pepper. Let's assume this machine is functioning properly and you have put your money in. If I press this button, what will I get? A Coke. But if I press this button, what will I get? I'll also get a Coke. It's okay that both of these produce the same value, produce the same product. It's okay that both of these are connected with the same Y value. This machine is functioning properly. This one is functioning properly as well. What would it mean for this to not be functioning properly? Well, what would it mean if this machine weren't functioning properly? You put your money in and you press the Coke button. Assuming it was loaded correctly, so that we can't say I push Coke and I get Dr. Pepper. So let's assume all the drinks are loaded properly. If this machine were not functioning properly, and I put my money in and press the Coke button, what would happen for you to say this machine isn't functioning properly? Well, one thing could be nothing comes out, meaning that you have a domain element that has no no range value paired with it. Or even better, you could push this button and 2 drinks could come out, or 3 or 4. When you press one button and get multiple outputs, multiple range values, that's when it's malfunctioning. But different buttons can produce the same value. Different X's can have the same Y. So it's okay that this 2 and this -2 are both paired with 4, because when I ask the question on the domain, how many range values? 1. How many range values? 1, 1, 1. You're grilling the domain, not the range. Let's take a look at the second relation. We've already got the domain and range, but is this a function? In order to answer, are you a function, I have to grill every member of the domain and ask a question. The question I have to ask it is, how many range values are you paired with? So let's start with the 2. How many range values is this 2 paired with? Well, let's go over here and see who it's paired with. This 2 is paired with the -2. So there's 1 range value. Oh, but wait. It's also paired with a +2. This 2 in the domain is paired with 2 different range values. That violates the definition of being a function. Each value in the domain is supposed to be paired with exactly 1 value. This is like pressing 1 button and getting 2 drinks. I press the 2 button and I get 2 outputs. I get -2 and I get 2. So that domain value is breaking the rule for being a function. It has too many range values paired with it. And it's not the only one. Which other domain value is violating the definition of a function? 1. The number 1 is paired with -1, but it's also paired with +1. So when I ask this question, when I ask this domain value, how many range values are you paired with? The answer is 2. That violates being a function. In fact, the only domain value behaving is the 0, because it's only paired with a single range value. So the answer to this is no, and it was no the minute I said bad X. It only takes 1 bad X to break being a function. So, you're a function if every domain value is paired with exactly 1 range value. Visually, you're a function if every domain value occurs only once. If a domain value occurs more than once, then you might be in trouble if it's paired with more than 1 range value.